Thank you very much. Okay, first of all, that's the first presentation I'm going to have in English. So I'm quite nervous and a little bit excited too. So I have these slides here. I'm going to read some of the points, just not to, just to be able to have the presentation the way I want to. Okay, good morning, ladies and gentlemen. My name is Waldemar Korte from the engineering office Mense Korte from Beckum. Our office designed, developed, and built the first printed residential building in Germany, together with the scaffolding and formwork company Peri and the materials supplier Heidelberg Materials. Today I would like to give you some insights into the first printed building in Germany, which is based in Beckum, and explain the planning process in 3D printing of buildings. Oh, okay. Well, let me shortly introduce myself. Before I started studying architecture in Münster, I became a bricklayer in order to gain practical experiences in the building sector. After my studies, I started working at Mense Werner Bayer and became one of the owners in 2015. In connection with the realization of the first printed building in Germany in 2020, we decided to found Mense Korte. So it's the same company, but another name. I divided my presentation in 3 points. The first one is the choice of a 3D printing process method we wanted to do, the BIM planning in 3D printing, and the last point is some impressions from the finished building in Beckum. First of all, I would like to speak about the printing process we chose for that project. The contour crafting procedure is well known among 3D printing professionals, as you all are, I suppose, because it represents the most promising type of printing large structures such as buildings. While I know most of you know more about contour crafting than I do, I want to give you a quick overview of how it works. So for most of you, it's nothing new, but it's just to complete the whole process. Okay. Contour crafting. When it comes to contour crafting, we put viscous building materials such as concrete, sand mixtures, and clay. They are built up over a scaffold by a mobile robot, layer by layer, based on a digital 3D model. So that's nothing new for you. The concrete mortar is extruded as fresh mortar through the nozzle via a screw conveyor, not in the pressure head, but in the print head. That's a mistake. And laid down as a layer of mortar with a pressure thickness and width. The route specified for the printer comes from the Planet 3D building model. So that what you see here is one of the first printing parts in the Beckum project. And you see the route for the printer, which comes from the 3D model we designed and developed in our office. Two main components are essential when we talk about 3D printing of buildings. The first is the printing material, and the second, the printer itself. Let us first take a look at the material. The printing mortar is not standard concrete because it must have several properties that normal concrete does not have. So if the material is hardening too slow, so that's the left picture you see, you get a good adhesion of the material itself, of the layers, but the mortar is sagging and you get non-uniform layers. So that's nothing we can build with in the construction sector. If the material is hardening too fast, you get uniform layers, that's great, but you get a bad adhesion, what leads to bad static properties of the whole construction. The optimal way is if you have uniform layers and a good adhesion between the layers. So that's the optimal. So you have to take care of the layer time you use for these constructions. We worked with the material of Heidelberg Materials, Heidelberg Cement, and the connected firm Italcementi from Italy brought the material to us. The material properties have to be, as you see it here, the material has to be pumpable, it has to be well extrudable, it has to be dimensionally stable at an early time, but it has to be long enough open to connect to the former layers. So that's what you saw at the pictures on the left. The printing machine is no less important than the material itself. The Beckham project was printed with a Cobot printer. Cobot is a firm in Denmark with E, which developed the machine in 2018. Perry is a Cobot joint venture and offers the printers for rent and for sale in Germany and other countries around the world. The print head moves around the 3 axes in a permanently installed metal frame and can reach any point in the print room. So the building we have got has to be based in the printing room. So the printing room shows how big a building can be printed in one. The maximum span of this printer from Cobot is 50 meters wide, 70 meters long, and 9 to 10 meters high. So that's the maximum you can print at once. If you want to print bigger constructions, you may move the printer. That takes about 1 day to remove the printer and to install it and to begin the print on the next day. So 1 day is enough for that. And if you do not want to remove the printer, it's possible to make it a little bit bigger because this whole system is modular. It's modular in the height, it's modular in the length and in the width. The next point I would like to talk about is BIM planning and 3D printing. So that's our main topic for us as architects. I'm an engineer and an architect, but I'm not a scientist, so I'm just concentrating mainly on this topic, planning of 3D printed buildings. Here you can see the floor plan of the Beckham project. The beginning of the planning process is relatively similar to common projects we know. First, you develop the floor plan together with the client. The first ideas could be drawn by hand on a piece of paper, so it doesn't matter. In the next steps, you start designing the building in CAD software. The 3D model will be essential for further planning steps which follow in the process. In 3D printed buildings, we plan the wall structures of different multi-layer wall elements. So that's what you already see here in this drawing. For the Beckham project, we decided to combine mortar lines which were 6 centimeters wide and 2 centimeters high. The printed walls are able to carry vertical loads from the slabs and horizontal wind loads. In addition, we had to add in situ concrete without reinforcement and cavity walls to complement the engineering concept, just to consider the safety aspect of that building. Because this building we constructed in Beckham is completely permitted, so there's already a person which lives in that building. That's not just a prototype. So it went into reality. It was okay. So what are the next steps when it comes to planning of that building? The 3-dimensional architectural model is provided with a lot of information. The technical trades have to provide their input at a very early stage of designing. The 3D model should be filled with information on reinforcement, outlets, and routes for technical trades. So that's what you see on the next picture. Here you see all the reinforcement in the in situ concrete, for example, in the slabs or in the columns you see here. And you already see all the pipes for the ventilation we had in that building, which are also included in this BIM model we developed in the office. Technical features of the specific printing process must be taken into account, such as the freedom of movement of the printhead. So it depends on the printer you have, it depends on the printhead you have. A hindrance of the printhead by reinforcement is to be avoided, and special elements such as lintels, cantilevers have to be considered. So all the different construction elements, all the different details had to be developed by us, because there's no book where you can have a look how such a detail works. You have these books for masonry, you have these books for common concrete or normal concrete, but not for the 3D printing of buildings. So we had to invent to develop all these details. So the next step you see here is from our architectural 3D model, you have to convert that building into a centerline model because the printer only understands, or the slicer software of the printer only understands the centerline model. So we have to transfer our model into a centerline model. In the centerline model, we check the files. If everything really matches well, we fix errors. If there are some in the file, we are fixing gaps in the model. And then when everything's done, we have to subdivide that model, that ground floor, in different printing sections. Because of the layer time of 15 minutes for the Heidelberg material, we are not able to print the whole ground floor in one step, because otherwise we would leave the layer time, and that's why we have to divide this building, the ground floor. You see different sections here in the different colors. We had a minimum 2 sections, but here we decided to have 3 because just to be on the safe side, so we have no problem of leaving the printing layer time. This picture shows an extract of the printing section of the first printing section. So that's a picture of the slicer software from the machine supplier Cobot. In this software, you are able to generate the travel moves automatically, but you also can change them. You are able to optimize the travel moves. So sometimes it's necessary to optimize them because the program is not that clever that everything is considered we want to have or we need to be considered. You can define the layer thickness, you can define the print speed, the layer time can be defined. And at the end of the day, you generate a G-code and transfer this G-code to the printer, because the printer only understands a code of numbers and not this centerline model. And that's the time when it first comes to the printing process itself on the job site. During the printing, there are also some adjustments which can be made. So you are able to adjust the printing speed, you are able to adjust the extrusion factor just to react to the environmental conditions, for example. Sometimes that's necessary. You are able to adjust the thickness of the layer. And in case of malfunction of the machine, what can happen, what often happens, not often, but can happen, you are able to get back to the recovery point where you stopped the printing, where you stopped the printing. You can activate the recovery point and continue printing at the same point where it stopped. So you do not have any gaps in the print itself. Here you can see some examples of the advantages of 3D printing in that building in Beckum. So because we integrated all the different trades in a very early stage of planning of the building, we were able to consider all these wall openings for electrical trades or for plumbing, for example. We were able to install the electrical sockets during the printing process. They are installed manually, but the printer leaves these cutouts in the wall. So there is no material where it's not needed, so you can pull the sockets inside. Another advantage is that you are able to print fixed installations like a fireplace, for example. So we integrated a fireplace in that building, and everything which is fixed in the building can be printed, because you're not going to remove these parts in a few years, so you can print them from concrete. And another point is you are able to print lost formwork for the in-situ concrete, which we needed for the statics for that building. Here you can see a reinforced column. We also just wanted to try out if it's possible to integrate reinforcement in the 3D printing process. So it is possible, but you're not able to, the reinforcement mustn't stuck out because the print head cannot move around the reinforcement. It's in the way of the printer head. So you have to work with a kind of reinforcement which can be screwed in. You know what I mean? Okay. And that's a possibility. So you're going to print 1 meter high, then you screw in the reinforcement, then you print the rest of the column, and then you insert the rest of the reinforcement from above into this column. And that's when the column is reinforced. You just put in situ concrete in it, and then it's ready. And it doesn't matter which geometry this column has got. Because of the 3D printing process, you are extremely free in designing such columns. On the picture on the left below, you see a pattern in a facade. So that's the next advantage we have. We are able to print in patterns into the facade without causing additional costs for the client. That's a big plus point for the 3D printing. And we just tried out everything in this Beckham project, what you can see here. And on the right side, you see a colleague who's inserting the insulation into the hollow walls we printed. And this insulation is made of perlite. Perlite? It's a volcanic material. It's a natural material which can be removed easily after the life cycle of the building. And last but not least, here's the nearly finished printed building in Beckham. As you can see, we printed nearly everything what's printable. We printed the not load-bearing walls and the load-bearing walls. And the whole printing process, everything you see here was done in 100 printing hours. Means that 50 printing hours, we took 50 printing hours for the ground floor and 50 for the upper floor. The 50 hours for the ground floor were splitted along 4 weeks. It took a long time to develop this whole printing process to optimize it. So there were a lot of lessons to learn in that time, the first 4 weeks. But we were able to optimize the process for the upper floor and to realize the upper floor in six days, only 6 days, with this 50 printing hours. The whole construction time took 8 months for that building. So that's construction time for normal, for usual building. And if you consider that's a complete new construction type, that's extremely fast at that moment. So we are sure and we are convinced that we are able to reduce the whole construction time of the building to 5 months, up to 5 months. What are the advantages? The advantages is that what's visible is the design freedom for architects, design freedom for the clients. It's short construction times. It's less manpower for the whole process. You only need 2 to 3 people for that job site, for the printing process itself. And you are able to save costs because you eliminate some of the other trades like plastering, like raw materials, raw electrical installations, because you're doing these trades in that time when the printer is printing the building. Here are some impressions from the finished building in Beckham. As you can see, the whole structure has been left visible because it was extremely important for us to show the printing process, the construction process. So the walls in the outer side and in the inner side are completely visible. Yeah, that's how it looks like. That's it. Thank you very, very much for the attention. Questions?
Hi, thank you very much for your presentation. I have one question. This is a first of a kind in Germany, this house. And I think you will do some follow-up models of it. How far are you with the legal aspects of DEBT? Is there only a, sorry for the German, the Zustimmung im Einzelfall, or did you already have the ABG and ABZ for that?
We have only got this Zustimmung im Einzelfall. It's permission only for that project, for that construction type, for that material. So if you change the material or the construction type of that building, you have to get a new permission for that.
Okay, but
so there's no DBT, there's no DIN norm at that moment. And I think that's very far away at that moment.
Okay, so that would have been my next question. When will there be something like that? Okay, thank you.
You're welcome.